My name is Lorenzen. I work for Dick Mathews in the engineering section of OPD's Personal Computer Business Unit. Lone Star is the code name for a proposed 860 follow-on product that is designed to bridge the office automation gap that exists between MemoryWriter and Star. This presentation explains what Lone Star is, what Lone Star's hardware and software might look like, and why Lone Star is critical to Xerox. The first question is, what is Lone Star? Lone Star is a desktop computer in the $4,000 price range capable of operating in the following three modes: MemoryWriter emulation mode, CP/M-based personal computer mode, and Office workstation mode. In its MemoryWriter emulation mode, Lone Star provides the customer with a direct typing capability in a manner similar to that available on the MemoryWriter 620. In its CP/M-based personal computer mode, Lone Star provides the customer with the capability of running the third-party applications available in the commodity PC marketplace. In its Office workstation mode, Lone Star provides the customer with an industrial-strength word processing package, an introduction to Star's user interface concepts, and a growth path via Ethernet to Xerox's Office of the Future. I should point out that Lone Star is not a Star. It will never provide the full-blown functionality available with Star. It is simply a low-cost, flexible, entry-level machine capable of smoothly transitioning the customer into Xerox's Ethernet strategy and Star's superior user interface concepts. Now that you know what Lone Star is, let's talk about what Lone Star's hardware and software might look like. Lone Star's minimum hardware configuration is based on the following: a processor module, which contains a 16-bit microprocessor, 128 kilobytes of RAM memory, 8 kilobytes of ROM memory, serial printer interface, keyboard interface, clock calendar chip, floppy disk controller, RS-232C interface, bitmap display controller, 6 expansion slots, and a multi-tonal sound generator. Low-profile keyboard with the mouse interface is also provided, and a partial page display with a resolution of 640 by 400 pixels. In the minimum configuration, only one floppy disk drive is present. With this configuration, the user can run both the MemoryWriter emulation mode and the CP/M-based personal computer mode. Running the Office workstation mode requires at least the following additional hardware: a mouse and a second 5¼ inch floppy disk drive. The UMC for this configuration is approximately $1,200. Additional hardware enhancements might include a full-page display with controller, color display with controller, rigid disk drive, 128 and 256K memory expansion cards, daisy wheel, dot matrix, and electronic printers, an Ethernet interface, a Z80 soft card, and other third-party expansion cards. One future Lone Star configuration might be a diskless, network-only workstation. The user interfaces for the MemoryWriter emulation mode and the CP/M-based personal computer mode of the product are fairly self-explanatory. However, the user interface for the Office workstation mode of the product is best understood by viewing the Lone Star demo. The Lone Star demo runs on the initial early bird hardware, which is a 5 MHz 8086 prototype system that was built approximately 1.5 years ago. The Office workstation mode software begins with a dynamic memory test program running with a bouncing icon on the screen. This represents the idle state of the workstation. Since the code name for the product is Lone Star, a Texas-shaped frame was chosen for the press any key message. I'm pressing a key now. The system goes out to the floppy disk and loads the user's desktop. The key features of the Lone Star desktop are as follows: a message line, a help icon, an auxiliary menu icon, and various icons to represent the objects on the desktop. You'll notice we've chosen low-profile icons because the screen space is one of our critical resources. First of all, I'll do a little typing. The particular font in the message line is a Helvetica 12-point font, which I obtained off of the Alto. You can see that the system can keep up. I'll hold the backspace key now. The system can keep up with the keystrokes and mouse movement at the same time. Next, let's do some of the common desktop actions. Clicking the left mouse button over any of the icons causes it to be selected. Only one object can be selected at a time. I've selected the memo document. Let's try a move. I'm hitting the move key now. You'll see that the mouse has been changed to a smaller version of the document that we had just selected, and the "Please indicate a destination with either button" message is displayed in the message line. I'll click the button down now to set this copy or this document down. See, the hourglass icon comes up as it's noted on the desktop. Another one of the desktop actions is a copy. I'm hitting the copy key now. In this case, the old version of the document left there is left on the screen, and we get another miniature version to represent the cursor. If we move up into an area where the icon cannot be placed down, we get a question mark, which indicates that that's not a legal position for that icon. I'm clicking the button now. And again, we get the hourglass. Now let's try a delete. You see that the "Are you sure you want to delete that object" comes up on the screen, and we can say either no or yes. And let's say yes. And the object is deleted. One of the other features that I've implemented is the help icon. If I click the mouse button in the help icon and let it up, it goes out to the disk to search for the help documents. Since this is only a prototype, there are no help documents available, as the message indicates. I click the button in the message line to get rid of that message. Another one of the features is the auxiliary menu. I'm clicking the button down now, and while still holding the mouse button down, I can move through the various options on the menu. Some of the options are permanent, such as end session, date and time, desktop, which is the standard mode of the product, and the CPM86 window. This allows applications which have not been integrated into the Lone Star interface to be run via a 25-line by 80-character window that gets opened up on the screen, if that were selected. The other two options on the menu, word processing and graphics, are there because of the disk that we happen to have in the system. You'll notice that on the diskette the name is WP and Graphics, and that indicates that those applications are present in the system and available to be run. Invoking those applications is done from the auxiliary menu. In this way, we differ from Star because we don't have the powerful processor that Star does, and also we're a floppy-based system, so we can't be modeless. We have to load the applications that we'll be working on. And another example might be an electronic mail application that could get placed into one of the disk drives, and then electronic mail would come up as one of the options on the auxiliary menu. This is also where third parties who develop applications using our set of utilities could integrate their applications into the Lone Star interface. We'll go ahead and select date and time. And there comes up the date and time. And I'll click the message line to get rid of that message. The final feature of the desktop that I've implemented is the ability to open a document. I'll click the memo document there, hit the open key, and you can see that the major features of the scrollable text window have been brought up. We have the header, which gives the name of the document, menu icons such as help and close, and then an auxiliary menu icon for this specific window, scroll bars, previous and next page, a sizing point in the right-hand corner, a right margin, left scroll, right scroll, and then finally a left margin. Since this was the last part of the demonstration software that was implemented, I didn't have time to do the gray shading that you would normally see in the header portion of the scrollable text window. However, that would be implemented in a product. This particular file was read off of a CPM-compatible disk, and each of the characters that was placed on the screen was done using a bit-blit operation. The code required to implement this demo took about 6,000 lines of code. The majority of that was in Pascal MT+, with bit-blit being implemented in assembly language. The one feature that I did implement on this scrollable text window is the ability to scroll up. And as I click the button, you can see that the scrolling of the text is marginal at best. We feel that but you have to remember that this is only a 5 megahertz 8086, and that if we go to an 8 megahertz 186 or 68,000, that will get adequate performance for an industrial strength word processing package. I'll go ahead and hit the previous page icon now. I'll now move over and close out this document. That concludes the demo. You can see that we can get back to the idle state of the machine by selecting End Session from the auxiliary menu. And you see that we go back to the Texas bouncing on the screen. I should point out that this is only a prototype implementation and is just the tip of the iceberg in terms of what will be required to turn Lone Star into a product. When Steve Thomas and I began work on this demo on June 28, 1982, we had 4 major objectives. These were to, number 1, develop an understanding of the system software considerations required to implement this type of user interface. Number 2, to demonstrate the hardware technical feasibility of this type of user interface on a 16-bit floppy-based system with a partial page display and a small amount of memory. Number 3, demonstrate the software technical feasibility of this type of user interface in a traditional high-level language like Pascal, running on an industry standard operating system like CPM. Number 4 was to develop a demonstration package that provides a visual straw man of a possible user interface that can be viewed, critiqued, tested, and revised by the rest of the organization. Now that you know what Lone Star is and what its hardware and software look like, let's talk about why Lone Star is critical to Xerox. I should point out that the opinions that will be expressed here are my own and do not necessarily reflect those of the management. I believe Lone Star is critical to Xerox for the following reasons. First, Lone Star is a transition product that allows our memory writer customers to gradually grow into the world of professional workstations communicating on a local area network. Second, Lone Star is a generic PC product capable of stopping the beachheads being established by IBM, Apple, and DEC on the desktops of those customers not yet ready for an all-encompassing office automation strategy. Third, Lone Star is an office workstation product that initiates the customer at a low price to the advantages of Star's user interface and protects the low end of the professional workstation marketplace. Fourth, Lone Star is a flexible, expandable product that allows third-party software vendors and major account DP staffs to develop value-added applications that have a consistent user interface and can share data. Fifth, Lone Star is a standalone product that can be loaned to our customers and our sales force to provide the hands-on experience required to appreciate what makes our workstation products unique. Sixth, Lone Star has an adaptable architecture that encourages third-party hardware vendors to develop enhancements that extend the capabilities of the base configuration. Seventh, Lone Star can be developed in time to diminish the impact of the Star clones being developed by Apple, DEC, and Corvus. Eighth, Lone Star can be positioned to support the subset of Star's functionality that provides the biggest bang for the buck, because unlike our competitors, Xerox already has an excellent high-end machine. Ninth, Lone Star software will be developed in a standard high-level language, Digital Research's Pascal MT+, running on an industry standard operating system, Digital Research's CPM, and therefore represents a body of code that can be easily ported to new hardware. Finally, 10th, Lone Star can be used as a vehicle for harnessing the creative potential of Xerox's large base of programmers who are familiar with bitmap technology and workstation software. For all these reasons, I recommend that Xerox develop the Lone Star product. If we don't, someone else will. Thank you for your attention.